Unit 9 review number 1. This is going to cover numbers 5 through 9. Number 5. Which of the following situations represent two independent events? Now, independent events excuse me, are events that do not affect one another, that do not change each other's probability. And this is choose all to apply, so we're probably going to have more than one correct answer. Part A. Picking a red M&M, eating it, then picking another red M&M from the same bag. Once you eat the M&M, that means you're not putting it back in the bag, which is changing the total number of M&Ms in the bag, which is changing the probability. So that means that this first probability of picking the red M&M is going to be different than the probability of getting the second red M&M. It changes that probability. That's dependent, which is not the one we want. We want independent. Part B, flipping a fair-sided coin and getting tails, then flipping it again and getting tails again. Now with the coin, whenever you flip it, you always have a probability of 1/2. There's two sides of the coin, heads or tails. Those do not affect one another. It does not change. The one half never changes when you flip it. So that is independent. Part C, choosing an ace from a standard deck of cards, not replacing it, big key phrase there, not replacing it, and then choosing another ace from the same deck. Since we're not replacing it, we're keeping that card out of the deck, which, like Part A, changes the total that are in the deck. So since that changes the probability, that again is dependent, which is not the one we want. And then Part D, using a 6-sided die, rolling a 4, and then rolling another 4. When you roll a die, it doesn't change what's on the sides of the die. When you pick it up, it doesn't change at all. So that is independent because those probabilities do not affect one another. Number 6, a bag contains 6 large blue marbles, 4 large yellow marbles, 2 small blue marbles, and 4 small yellow marbles. A marble is randomly picked from the box. No, that should say bag. What is the probability that it is one of the large marbles given that it is yellow? Remember, when you see given that it is yellow, this again becomes the new total for your probability. So your probability loads an event over a total. Now, since it says given that it's yellow, that means we're only working with the yellow marbles. So if we go back through this, 6 large blue marbles, that means we can cross that off. 4 large yellow marbles, we want to keep that one. 2 small blue marbles, that's gone. We're not using, again, any of the blue marbles. And 4 small yellow marbles, there's another one that we want. So again, back to the probability that they're looking for. The probability that it is one of the large marbles given that it is yellow. So out of all the yellow, there's 4 plus 4, that's 8 total yellow marbles. Of those, the event on top would be the large ones. There are 4 large, which means our probability is 4 out of 8, which reduces to 1/2, which is 50%. Number 7, a spinner is spun 200 times. How many times would you expect a prime number to come up? So we have 200 spins. We have to find the probability of the prime number first. That's going to multiply with our 200 spins to give us what we expect to happen. Now, of these 4 numbers that are on the spinner, the only one that is not prime is the 4, because 2 goes in the 4, 1 goes in the 4. 1, 2, and 3 are all prime numbers. So out of these 4 total numbers on the spinner, 3 of them are prime, and that is our probability that we're working with. That probability now has to multiply with our 200 spins. Over 1, 3 times 200 on the top is 600, over 4 times 1 is 4. 600 divided by 4 is 150, so we're expecting it to come up 150 times out of those 200. Doesn't mean it's automatically going to happen, but we expect 150 times for it to come up as a prime number. And number 8, Roscoe, the owner of Roscoe's Chicken and Waffles, collected data on customer choices for several years. His customers chose just chicken on 40% of his visits, just waffles. Let me go ahead and highlight first. Just chicken, 40%. Just waffles, 30%. And then both chicken and waffles, there's a big keyword and, both chicken and waffles, 50% of the visits. So they're giving us three different probabilities. Roscoe wants to use these data to predict future customer choices, assuming that they follow the trend of previous years. In particular, he wants to know what is the probability, so here's our question that we have to answer. What is the probability that a customer will choose either chicken or waffles? So we're finding an or probability. Roscoe has hired you to find this probability, so you'll have to get the answer or else he will fire you and you won't get paid. So, since it is an or probability, this is again, we're finding the probability of either chicken or waffles. The or probability formula is first finding each individual probability, the probability of chicken, probability of waffles, and subtracting the probability of both chicken and waffles. Now, if you read this properly, they've given us all three of these things. The probability of chicken, look at the orange highlighting. It says customers chose just chicken on 40% of the time. That means that this probability of just chicken is 40%. Plus the probability of waffles, just waffles in the blue, on 30% of the visits, plus 30%. Minus, now probability of chicken and waffles, both chicken and waffles on 50% of the visits. So they've given us in the problem all three that we needed. So now to get the probability of either chicken or waffles, add our 40 plus 30, subtract our 50. 40 plus 30 is 70, minus 50 is 20%. So the probability of chicken or waffles is 20%. Last one for this video, number 9. 6 students roll the die 10 times each. They get the number of ones shown in the chart below. So they're saying that student A rolled 1 1 out of his 10 rolls. Student B rolled 3 1s out of his 10 rolls, and so on all through the chart. It says, which of the following statements is correct? The total number of ones is more than expected. Now, if we look at the total, and they're saying the total for all the students all together. Remember that each student rolled the die 10 times. 1, 2, 3, 4, 5, 6. That means 6 times 10 is 60 times that they in total that they rolled the die. When we add these up, 1 plus 3 plus 1 plus 2 plus 2 plus 3 is 4, 5, 7, 9, 12. Out of the 60 rolls landed on the 1. So when they roll the dice, these students land on 1 12 times. Now when they talk about expected, on the dice, for the expected value, it's kind of like if we look at this spinner problem from number 7. We expected, because of this probability 3/4, that spinner to come up on a prime number 150 times, because we took the probability and multiplied by the number of spins. So here, our probability is out of the 6 sides on the die, only one has a number 1 on it. We are taking that times the total number of spins, which is 60 over 1. That's 60 over 6. So we're expecting it to land on a 1 10 times. Now the total number of times it actually happened was 12. So here the total number of ones is more than expected. That is more than our expected value of 10. So that is correct. Now just to make sure that none of these other ones work, the total number of ones is less than expected. 12 is not less than 10. The total number of ones is equal to the number expected. Nope. The total number of ones expected cannot be predicted. Well, we can make that prediction because we have the probability. And we predicted 10, that landed 12, which was more than that. So number 9 should just be A.